My name is Kipp, and thank you for having me. I'm really happy to be here. Today, I'm going to talk about Scala development with Vim in 2020. Just a little bit about myself. I actually grew up in the United States on a farm. And then I studied international relations. And then after grad school, I made a switch to tech. And then after that, for a while, I moved to the Netherlands, and now I'm a software engineer at Lunatech Labs, and we do a lot of Scala and Java development with a lot of big data, and we're a consultancy company. We're always hiring too, if anybody is interested in that sort of thing. And then in my free time, I really enjoy working on tooling and minimal tech. Related to that, and I'll get into it, but the logo I didn't mention, but I'm also one of the maintainers of Metals, and then also wrote the Vim extension for Metals, which we'll be talking about a lot today. So my goals for the talk, first of all, it's not to convince everyone here to switch to Vim and Metals. I feel like that might be the assumption of as soon as somebody says someone is doing a talk about Vim. But instead, I really would just want to show that Vim is not only a viable editor for Scala, but is actually really well supported and feature rich in the ecosystem. I want to show how fast it is to get up and running with Metals and Vim. And then I want to talk a little bit about how Metals accounts for different clients. And during the presentation at all, if you have any questions, there's the group chat that you can send them to. If it's something really quick, I'll try to answer it if it's related to what I'm talking about at that moment, or I'll try to answer them at the end. Or I believe they are also doing like a Q&A session as well afterwards at a different time. So the first thing I want to talk about is that Vim isn't going anywhere. So Vim was created in 1991, and ever since then, it's remained to be a really popular editor. If you look at the last 3 years of Stack developer surveys, whether you think they're like really important or not, Vim has remained in the top 5 editors every year. Even this past year, as we saw Visual Studio Code like skyrocket into being the most popular editor, we still see Vim tied, for example, with IntelliJ in overall usage. Some of that might be a little bit hard to gauge because of things like DevOps, and where you may not actually have like an environment locally that you're using, so you're just using Vim on a server. But either way, it's safe to say that Vim is probably not going to go anywhere soon. If you look at the 2008 Scala developer survey, you see that the vast majority of users were using IntelliJ. You do see a few other editors represented here, but no Vim, for example. And then you see a small percentage at 5% of Enzyme, which I think a huge percentage of that was actually Emacs users. But you can probably assume that there's a really small percentage of Enzyme users that were using Vim as well. However, this last year, you see something a little bit different happen. It's a little bit unfortunate how it was worded, but you see that it says Metals plus another text editor. So if you're a Vim and Metals user, you fit into that category. But then there's also a text editor category where Vim is included. So I don't know if like people were confused about which one to answer or not. But either way, it's safe to say at least a little bit that there is some Vim representation in the Scala community. And hopefully the more support that people realize Vim has, the more they will actually consider it as a viable editor while doing Scala. A second part of that that I think it's important to note right away that Metals isn't going anywhere. I mentioned that the 2018 Scala developer survey showed the vast majority of users using IntelliJ. However, the number between 2018 and 2019 went up pretty drastically. And now we have almost a third of Scala developers, according to the survey, that are using Metals in a various text editor, with the majority of them using VS Code. The second point to that, I think, is that Metals isn't going anywhere either, because I would like to say there's a really solid team behind the development of Metals. For example, in the beginning, we had Olafur Gierson and Gabriela Petronella, who did like a lot of the groundbreaking work on starting it, along with some other individuals. And now, for example, we have Thomas Gotzik at Virtuous Labs, and they have a whole group of people that are working on Metals, doing a ton of work. And then there's also a whole bunch of other contributors that are actively contributing to the ecosystem of Metals. So I think it's a good sign to see how many people are actively involved in Metals, that the usage is rising. So I think it's pretty safe to say that Metals also isn't going anywhere. So that brings me into Vim and Metals together. If you're unfamiliar with LSP, LSP stands for the Language Server Protocol. And to give like a very, very, very brief overview, it's simply just a shared protocol between client and server that communicate back and forth with one another. If you're doing something like give me all the references for this symbol, or give me the type definition at this point, or do a rename. Most of the time, the client either has an LSP engine built into it, or it has pretty much one extension that is the de facto standard one. For example, Visual Studio Code is kind of like the perfect example of this because LSP is baked into it. Both LSP and VS Code being built by Microsoft, they have such a really like a tight coupling, and it works really seamless. With Vim, it gets a little bit trickier because you need an extension that gives you LSP support. And as you can see, there is like 7 or 8 different options. They all have like their differences. Some are more popular, some are less popular. Some have more LSP support, some have less LSP support. So I want to do a little bit of exploration about which one I recommend, which one I think has the best support for Scala, and why that is. And as you'll see, like the smiley faces show what my 3 recommendations are, and I'll go over the 3 of those as well. The first thing I want to talk about is the number one that we recommend, and that you also see represented on the Metals website, is Conqueror of Completion, or COC as you will always see it. It's actually written in TypeScript, and it's an IntelliSense engine for Vim and NeoVim. And the nice thing about COC is that it shares the same level of support of LSP as VS Code does, because it actually shares the internals. It rips them out of VS Code and shares the same thing with Vim. So the cool part about that is it allows you to reuse VS Code extensions, and they have an extremely responsive team as well, which is really nice. Because of that, we chose to make COC Metals, which is actually a COC extension, which you install using coc.neovim, which offers you everything from automated installation of Metals to automatic imports, to kind of everything that you would expect out of the box when you're starting with an editor and a language. And the reason why we again chose to build the extension on coc.neovim instead of one of the many other extensions is that it's both really extensible and really easy to make a wrapper around it to offer a lot more extra helpers. But then we were able to actually use the VS Code extension and take the core part of that and bring it over to Vim and use it there as well. So we actually have a shared library between COC Metals and the VS Code extension that we use for Metals. So I want to do a few demonstrations that you'll see in the background. Most of them are, I'm going to kind of like skip over hovers and finding references and those types of things that you would probably say are like the bare minimum of what you would want out of an editor, an intelligent type editor. And even you can kind of see in the GIF in the background right now, just a little bit of navigating around just to show that you can do that. But I want to touch on some of the things that are a little more feature rich maybe that you wouldn't expect. And one other thing I want to mention is all the examples that you're going to be seeing, they're not in any type of GUI program or anything. They are straight in the terminal. So every one of these examples is running in the terminal with NeoVim as well, which is something I'll talk about a little bit. So one thing that was really important to us is if you think of Vim or Emacs, sometimes people think automatically that installation and customization is like a nightmare. It's so hard to set up. So it was really important to me when we started to write it to do it in a way that was really easy to get started. So for example, if you split it up into 3 steps, you should be able to get started. And the first one is just using and installing the coc.neovim plugin, which you can see on the top line. We provide with you recommended mappings, which all you need to do is copy them and paste them into your vimrc. Obviously, spend some time customizing them to your liking. But you see under 2.1, there's an example there of, for example, the mapping that you would need to do a rename, which would allows you to just do leader RN on top of a symbol and then rename throughout the entire workspace. After those are there, then you have multiple different ways to actually install Metals. So the easiest one is just COC install COC Metals, which installs Metals. And then if you don't have, it installs the extension actually. And if you don't have Metals installed, it will automatically install Metals. And you never actually even have to leave Vim to install it. You could update your version and it would re-download the new version of Metals, bootstrap it, and start it with all the configuration values. And you can do that all within never actually leaving Vim, which is a huge improvement over just like bootstrapping it on yourself. And this is all with the assumption that you have Node and Java installed in your machine as well. The moment that you open up a workspace where they detect a build.sbt or build.sc or Gradle environment or pom.xml or anything, it will prompt you to import to build, just like you would experience in any other editor, like in VS Code or something using Metals. We also offer code actions in Vim. And if you're unfamiliar with code actions, but you are familiar, for example, with using IntelliJ or VS Code, and you see the little light bulb that appears and you can click it, and then it offers you a whole bunch of different things. We have that same concept in Metals. And what you're seeing here is just one example of where we have something that's not in scope and we need to import it. And you can trigger a code action on that symbol with the diagnostic and import it into scope. And we have, I think, three total code actions. There's another one that is to implement all the missing abstract members in a concrete class, and then also to create a symbol. And now that we kind of have the foundation and groundwork laid for code actions, we can continually add more and more of them as well. LSP doesn't actually cover every single thing you would expect or want. So what they have is something called LSP extensions, which is what you're looking at right now. The tree view protocol is actually something that is an LSP extension built on top of the protocol. What this allows you to do is when you're navigating through code, in this example, like we're on trait completions, we're able to jump from the file where the trait is defined right into a tree view of where completions is, and then you can navigate through all the members of that. And then, for example, pick one of those members and then jump right back into the code where that's located. So it's a really nice way to navigate around your code base and explore an API. And this is all built into the Vim extension as well. Another one of my favorite features that you may not expect to have in Vim is worksheets. This is specifically, again, using NeoVim, where you have virtual text. If you're just using normal Vim, you would only have comments on the end. It would still work, but it just looks a little less polished, I would say. But in this scenario, you're actually seeing like a live evaluation happen in the file. On the right-hand side, you get like a little preview of what the evaluation is. And then you're able to actually trigger a different type of hover on that line to see the extended view of what it evaluated to. We also really wanted to make it super easy to configure. Again, Vim sometimes is known to be like really difficult to configure. How do I set all the values? Metals has not a ton, but like a good chunk of configuration values that you can pass in. Like if you have a custom path for your Scala format file, if you have an SBT script that you want to pass in, we make it really easy to fill in these values. You get auto completion, you get descriptions as you're scrolling through them. And again, this can all happen while you're in Vim. You never have to leave and go to your vimrc file and assign everything there. You can do it all from within Vim in a nice like configuration file, like you're seeing here on the screen. Another thing that it offers is a lot of quick commands. So as you would expect in an IDE, like you want to be able to click on something and say create a new file, and it creates a new file with maybe the name you gave it, and you said you wanted a class, so you want the class to be automatically named, and you want it to have the correct import or like the correct package declaration, and that can happen here as well. As you see, these commands that you see at the bottom of the screen allows you to do things like create a new Scala file and create a package object and things like that. It also has a built-in doctor. So when the image is actually showing me in the Metals code base right now, and I just wanted to make sure, hey, what Scala versions am I using? Are diagnostics, go to definition, completion, references, is everything working okay? I can quickly hit a command that opens up the Metals doctor right in Vim and shows me I have green check marks across the board that everything is working as expected. This one is one that's actually not merged in yet, but it's really close to being merged in. The majority of the work isn't done in the extension at all. It's actually piggybacking off another extension called Vimspector. But it allows you to go through your code, set some breakpoints or no breakpoints, and then run or debug your code. And as you can see the stack trace in the bottom left-hand side. You could see the variables in the top left-hand side, and then the bottom right-hand side, as you're actually stepping through the code, you can see what it's evaluating through. And again, this is all happening in your terminal, and it's as simple to set up as making sure that you have the other plugin installed, and then we take care of all the communication between Vimspector, Metals, the COC extension, and you can run or debug your code right in the terminal in a matter of like a minute. So it's really well integrated. So that kind of goes over the extension that the team has specifically for Metals, but there are some other alternatives that you might want to consider. You have to do a little bit more work to install them, and I'll show you an example of what that looks like, but it still works really well. So if you're somebody who doesn't want to worry about having Node on your computer, you don't want like a larger experience, I would say the coc.neovim experience is for the VS Code user, or basically the Vim user that wants VS Code in Vim. And that's what it offers you, is almost not everything that VS Code does, obviously, but it offers you a lot of features. If you're somebody that wants a more minimal setup, that only wants the extension, for example, written in Vim script, but still covers like the core of LSP well, then I would really recommend for you to look at Vim LSC. It's really easy to set up. And it's like 5-10 lines of configuration, and you install it, you bootstrap Metals, and it connects, and it works pretty well. The one that I'm really excited about, that I would say that people should keep an eye on, is in NeoVim. And if you're not familiar with NeoVim, it was sort of a fork away from Vim a few years ago. They wanted to, in theory, clean up the code base and change some things, and they, I would say, pushed the world of Vim forward by introducing things that Vim didn't have at the time. Now they're much more compatible, but I would still say that NeoVim offers some new features that Vim doesn't, that might interest you, like virtual text and things like that. Really recently, NeoVim has merged in a built-in LSP directly into NeoVim. And I honestly think that that's the best way to go about it, because you don't have to worry about another extension. The integration can be really smooth, and ideally, that's exactly what you would want. There's also some automated installation of servers that you can do, and it's sort of a like more extensible approach that allows you to write some Lua scripts, and it helps you and gives you more helpers as well. But keep in mind that this option is pretty much experimental at this point. So this does take quite a bit of setup. Not all of LSP is covered, and you're probably going to find things that don't work well or break until it's not even in the LTS version of NeoVim yet either. So then the question kind of becomes, how does Metals account for different clients? As you can see, even between the last 3 versions of LSP clients I showed for Vim, there's differing levels of support. coc.neovim offers almost a full feature set. Vim LSC offers a subset of those, and then NeoVim offers an even more limited subset of those. So we do that in 3 different ways. And the first way we do that is by passing in server properties when we bootstrap Metals. So for example, if you're using Vim LSC, you would need to do a script like you're seeing on the screen, where you're using Corsair to bootstrap it, and you're giving the artifact, and then you're telling where to find it, and then you're passing in, for example, -d Metals client Vim LSC. And what that is doing is it's basically telling Metals, hey, when you start up, this is all the settings that we want for you to start with, because we know this is what Vim LSC supports. I think probably if we would like go back in time, we would try to do as little server properties as possible and do them in other ways, which exist in LSP now. But at the time, I don't think the team really knew that or thought about that. So it seemed like a great idea. But I think now we're trying to take an approach where we have a different method of doing that. One of those different methods is called initialization options. And again, if you're unfamiliar with LSP, the way that it basically works is that the moment you start your client up and you have an LSP connection, it will say, I support A, B, C, and I do D this specific way. And then it knows that, hey, I'm in a Scala file, so I must be sending this initialization request to the Scala language server, which in this case is Metals. So then Metals would receive that and look over it and then send back, hey, as the client, this is what I support. I also support A, B, C, and I know that you do D this way. So, okay, I will keep that in mind, and that's how we move forward. Another way to specify what specific clients do is by this field you see here called initialization options. So you can put, as you see, any value in here, but you can put any type of values in here that the server can pick up to know, for example, how and to treat a client. Another way that we set certain things, as you saw a little bit earlier with the tree view protocol, the tree view protocol isn't actually part of LSP. It's an extension on top of LSP. So it's not necessarily experimental at this point because it's pretty solidified, but at the same time, we can pass in an experimental flag saying, I support the tree view protocol. So Metals knows when it bootstraps for that specific client, it can see under the experimental capabilities that it supports the tree view protocol. And then moving forward, it will send you all the notifications and all the updated information about tree views. So between these three different ways, Metals is able to really fine tune the experience for a VS Code user or a bare minimal Vim user that doesn't even use our extension, for example. So Metals does a really good job of knowing who's using it and what it needs to provide for it as well. So then the next question is, what about the future? We saw that there's a rise in Metals usage. Vim doesn't seem to be going anywhere. So what ideas do you maybe have about the future, or where do you think the future of Vim development in Scala is going? And I would say one thing that's really important for me is to continue to try to attempt to have parity with VS Code and Metals. I think that VS Code and Metals gives the user such a rich experience right now and such an easy onboarding process that I want to try to be able to offer as many features as we can with the Vim extension as you could do in the VS Code extension without making Vim feel like it's a giant ecosystem. So still respecting the ideas of what Vim is. I also think in the next year, you'll see the LSP client that's built into NeoVim really take shape. As you saw, I think the example I gave had like 600 stars or something. Keep in mind that that repo is just a group of settings for NeoVim of how to install various language servers and how to set them up. And the feature is not even in the latest release of NeoVim. So if something has that much support and interest already before it's even merged into LTS, I think you'll see pretty widespread adoption in the Vim world for those who are looking for an LSP experience in Vim. The third one, if you're somebody who doesn't necessarily want to use Vim in the terminal, but you do want to use Vim key bindings, a lot of people will, for example, use VS Code with Vim key bindings, but a different approach to that is only Vim 2, which sort of takes that and flips it around. And instead of having VS Code with Vim bindings, it's more like having a GUI version of Vim with VS Code features. They actually share the internals for extensions, so you can share extensions more or less, and it gives you a really rich experience. And then finally, the Scala syntax for Vim hasn't really been touched in the last few years. There's a really well-known Vim Scala from Derek Wyatt, which gives you some basic syntax highlighting. It allows you to, I think, sort imports and a few other things that I would say aren't necessarily needed anymore with some of the tools we have, like Scala Fix and Scala Format. And it doesn't account for some of the new syntax that is in Dotty as well. So something I want to personally work on in the upcoming months is providing a new alternative syntax package for Vim, which both accounts for Dotty and also only does the minimal things that we needed to do in relation to some of the other tools that exist as well. And final tips that I have for COC Metals users, these are things that I come across often where people ask me like, what's a tip for using COC Metals? I would say make sure you have the status bar enabled set to true. It gives you, by default, we don't set it on because we can't guarantee a user has a status line integration. So we default it to false, which then just shows you like short messages in your message buffer, where if you have status bar enabled set to true and you set up a status line integration, you get really nice status messages in your status bar. Also make sure you set code lenses enabled to true, which will allow you to see the run and debug buttons when they come out. And we have a new feature that's in the Metals snapshot where you can jump to super methods. And you won't be able to do that without having code lens enabled in the extension. Also spend time customizing the recommended mappings. Like you can just paste them in, I guess, if you want, but also maybe spend a little bit of time going through them, understanding what they are, and changing them if you want. Give NeoVim a try if you're a Vim user. I'm a huge NeoVim fan. And then also make sure to use the built-in commands, such as creating a new Scala file, reveal in tree view, and all the other ones that exist, like restarting your Bloop server and stuff like that. And that's it and all the time I have. I only have a few minutes left, but that's my handle on Twitter and GitHub. My slides are located there. And then I also have the repos for both Metals and the Vim extension that all the GIFs were from, which is COC Metals. And again, I'm at Lunatech. We're always looking for people. So if you do have any questions about that, please let me know. That's it.
Thank you very much, Chris.
Yeah.
Any questions?
Yeah, first of all, thanks for the great talk and shedding light on the new Vim. In my opinion, it's vastly underappreciated. But the only option for someone who wants to get all the features from the IDE is to use COC, right?
If you want all of the extra features, yes. Like if you don't use COC and you still want to send in server commands, you can technically still do that. You just have to somehow figure out how the extension sends those messages to the server. So even if you're using like Vim LSC, for example, you can bootstrap it the way that I showed you to. Then in your Vim RC, you'll probably have to create a shortcuts or some type of mapping that will probably do like LSC server command, and then you define what the command is and it would send it. So in theory, it has the ability to work. You would just have to like play around with how to actually make it work, if that makes sense.
Mm-hmm. And the debugging support is included in Metals, or is it a part of COC? Or
yeah, so the debugging support, the core debugging support is provided by Metals and Bloop. But then in order to access it, you have to set a flag in the client that says that you support debugging. So COC Metals actually doesn't do a whole lot except for setting that flag and then setting the correct parameters, and then we pass it off the Vim Spectre. So even if you're not using COC, for example, and you're using another one, you can actually still use Vim Spectre, and you could probably copy over the settings that we will provide and then use them for the other editor as well, because they're not like tightly coupled at all. We set them up. That's all we do. So you will be able to use that with Vim Spectre. Like you could already use it if you know how to set it up right now.
okay, thanks. And you said that auto importing is supported somewhere at least, right?
Yeah, so if you want automatic imports, there's multiple ways to do it. If you are doing a completion of like Java time instant or something, and instant isn't imported, and you autocomplete that, it will automatically import it. Or if you like paste it in there, you can trigger a code action on it, and it will show you the symbols that it thinks that you want to import, and then you choose which one you want to import.
Okay, thanks. And the last questions, are there any like comprehensive guides or manuals somewhere to get it all up and running? Or
yeah, I would say take a look at either the website under the Vim section or the README of the COC Metals GitHub. I've done a lot of work on trying to make sure it's like really well documented. So I would say there's like extensive documentation on how to set up COC.NeoVim. I would say there's not extensive documentation on how to set it up for other clients, but if you have questions, you could always ask either on the Gitter channel or on the Discord channel, and I'm happy to help for Metals.
okay, thanks a lot.
Yeah.